Okay, this is 4.2, Elvira's equations, a solidify understanding task. And this we're going to continue to work on our ability to solve literal equations and really work on using variables and the meaning of variables and the units we're using. This is a great activity. There's a lot of hyperlinks in this activity, so I usually record like 1 or 2 slides at a time, but I'm going to try to go through the whole thing because of the hyperlinks, which means we might hit a bump in the road here and there. That's okay. That's what learning is. So, Elvira, the cafeteria manager, likes to keep track of the things she can count or measure in the cafeteria. She hopes this will help her improve the efficiency of the cafeteria. To remind herself to keep track of important quantities, she has made a table of variables and descriptions of the things she wants to record. Here is a table of the things she has decided to keep track of. So, cafeteria manager obviously has to keep track of a lot of things. All right, and you'll see in this table, the left column would be the symbol or the variable that Elvira is going to use. The middle column would be the meaning of each variable, and then the right column would be the units that are being measured by each variable. Important stuff. So, let's take a look here. The symbol S stands for the number of students that buy lunch in the salad line. So, what's being measured there? Number of students. Units, what is counted or measured? Students. W, the number of students that buy lunch in the sandwich line. And again, what's being measured there? Students one more time. P, the number of students that buy lunch in the pizza line. And again, what's being measured? Students. F, the number of food servers in the cafeteria. And that would be number of servers. M sub T, the number of minutes it takes to serve lunch to all students. So minutes total is what they're talking about right there, M sub T. And what is being measured? Time in minutes. C, the number of classes in the school. And what's measured there? Number of classes. And then P sub L, price per lunch. That makes sense. So what's being measured there? What's my unit of measure? All right, that's in dollars probably. Yeah, dollars. Okay, so Elvira has written the following equation to describe a cafeteria relationship that seems meaningful to her. She has introduced a new variable, A, to describe this relationship. And notice that A is the next symbol in our table right there. So A equals the quantity S plus W plus P divided by C. So I wonder what A means right there then. Let's think about that. What does A represent in terms of the school and the cafeteria? Record this information in the table above. So we can use the variables on the right to come up with a meaning for the variable A on the left. So let's start with this numerator right there, meaning. Okay, well, S plus W plus P, that would be the number of salad lunches sold, the number of sandwich lunches sold, and then the number of pizza lunches sold. And that's all the lunches that they sell. They have 3 types of lunches. What, again, salad, sandwich, or pizza. So that's just total lunches. A, number of students buying any lunch. Okay, and then C, well, C was the number of classes in the school. Number of classes. So let me see. If I took the number of students buying any lunches, so that's the total students that buy lunch, divided by the number of classes, then wouldn't that A represent the number of students per class that buy any lunch? Let's see. Number of students per class that buy any lunch. Look at that. And what's being measured there again? Students. Okay. Let's see. Let's make sure we answered this. What does A represent? Number of students per class that buy any lunch. in terms of the school and the cafeteria. Record this information in the table above. Great, we're good. Nice job. Okay, it looks like I need to go to this hyperlink for number 2 and 3 here. So, number 2, using what you know about manipulating equations, solve this equation for S, the number of students that buy salad. Your solution will be of the form S equals an expression written in terms of the variables A, C, W, and P. So this is called a literal equation. Now, algebra students tend to struggle solving literal equations, but if there were just one variable, that always seems to be a little bit easier. So just think about what would we need to do to isolate the S, the variable that we want to solve for. All right, and the order you do these steps is really critical right here. Now, if I look at this, do you guys see that the quantity S plus W plus P is being divided by C? So the first thing I would want to do is get rid of that division by C. So what is the inverse of dividing? Multiplying. So to undo division by C, we would simply multiply both sides by C. Now let's rewrite the equation, and remember what we do on one side of the equation we always do on the other side. So on the left, I'm left with C times A, and on the right, these C's would cancel, leaving me the quantity S plus W plus P. All right, now to solve for this S right here, probably let's get rid of this plus W. So what is the inverse of adding W? What undoes it? Subtracting W. So let's subtract W from both sides of the equation. So break down our equals. And now on the left, let's just combine terms here. And there's no like terms, so we're just going to write this the way we see it. CA minus W. And then on the left, the plus W and the minus W would cancel out, just leaving us the S plus P. And now we have one more step. We're isolating the S, so let's get rid of plus P. What is the inverse of adding P? Subtracting P. There you go. Now rewrite your equals. And now let's rewrite this, and there's nothing I can combine, so I have to write it the way I see it. CA minus W minus P. And what does that equal? S plus P minus P is just S. And we've done it. S equals CA minus W minus P. So let's go back to the question. Using what you know about manipulating equations, solve this equation for S, which we have done right there, showing every step nice and neat. Great job. Your solution will be of the form S equals an expression written in the terms of the variables A, C, W, and P. Perfect. So number 3, does your expression for S make sense in terms of the meanings of the other variables? Explain why or why not. All right, well, let's think about the meanings of our variables. Okay, what would that C times A represent? Okay, so let's go back to our table and make sure we have these meanings. C times A. Okay, well, C is the number of classes in the school, and A is the number of students per class that buy any lunch. So wouldn't C times A simply be the number of students who buy lunch? So I'm thinking about the number of students who buy any lunch at the school. Let's see. Yeah, the number of students buying any lunch. Okay, minus W. And W was the number of students, I remember this one, the number of students that buy a sandwich lunch. Okay, and then isn't P the number of students buying a pizza for lunch? The number of students buying pizza for lunch, there we go. Now, what would that make S then? Okay, if I have the total students buying any lunch, minus the number of students that buy sandwich lunch minus the number of students that buy pizza lunch. Well, what's the other lunch? It's the salad, and that would be the number of students who buy salad lunch. So S equals the number of students who buy lunch in the salad line. And let's go check that on our table, see how we did. S, the number of students that buy lunch in the salad line. Beautiful. So that makes total sense. One more time. Does your expression for S make sense in terms of the meanings of the other variables? Explain why or why not. Beautiful. Okay. Yes, it makes sense. Okay, number 4. Here's another one of Elvira's equations. Oh, look, and they're using subscript notation there too. R equals P sub L times the quantity S plus W plus P. What does R represent in terms of the school and the cafeteria? Record this information in the table. All right, what does R represent? Well, let's see. I'd need to know what P sub L represents right here. Okay, so P sub L. Think about that. P sub L, maybe price per lunch. Let's double check that though. P sub L, did they give me this? Yeah, price per lunch right there. Okay, and that was number 4, I believe. There we go. So the price per lunch. And isn't this quantity the number of salads plus the number of sandwiches plus the number of pizza lunches sold? So that's the total students that buy lunch right there. Number of students buying any lunch. So price per lunch, like say lunch costs $3.25 times the number of students buying any lunch, wouldn't that give me the total amount of money that the cafeteria brings in a day? And we like to call that revenue. So let's see. I'll bet you that R stands for revenue. Daily revenue brought in by the cafeteria. Let's add that to the table. R, daily revenue brought in by the cafeteria. And what is the units being measured there? That'd be in dollars. Nice. Okay, where was I at? Was that number 6 already? No, that wasn't number 6, so let's get back to the table. That must have been this hyperlink for number 4. All right, yeah, there we go, number 4. I was getting ahead of myself there. Okay, things are looking really good right now. So, here's another one of Elvira's equations. Okay, that's the same one. Okay, but another question about that equation then. Using what you know about manipulating equations, solve this equation for P sub L, the price per lunch. Okay, so P sub L. Well, P sub L is being multiplied by this quantity right here. So to undo that, I could do this in one step. Let's divide both sides of this equation by the quantity S plus W plus P. There we go. Now let's rewrite. And now you can't combine anything over here, so you want to write it just the way you see it. R over the quantity S plus W plus P. And you really wouldn't need the parentheses in the denominator, but I left them there just, I'm dividing revenue by the total lunches sold, the number of students who bought lunch. All right. Now over here, those quantities would just cancel, because when you have these parentheses like this, that's just like one factor. P sub L is being multiplied by S plus W plus P and then divided by S plus W plus P. Those would just cancel out and leaving P sub L. And we have solved for P sub L. Okay, using what you know about manipulating equations, solve this equation for P sub L. Awesome. Okay, number 6. We're here. Number 6. Does your expression for P sub L make sense in terms of the meanings of the other variables? Why or why not? Well, let's think about the other variables. Now, wasn't R the revenue? Let's double check and make sure we agree with that. R, daily revenue brought in by the cafeteria. Yeah. Okay. And then S plus W plus P, wasn't that the number of students buying any lunch? Because that's all my lunches right there. Number of students buying any lunch. Okay, so let's think about that. Daily revenue brought in divided by the number of students buying any lunch. Would that give me price per lunch? That makes total sense. So that works. Price per lunch. Yeah, makes sense. Okay, so let's see. I think our table's all updated, so we can just move on. Number 7. Elvira notices that she uses the expression S plus W plus P a lot in writing other expressions. Yeah, we've seen that many times. In fact, what have we been calling this? S plus W plus P, number of salads plus the number of sandwiches plus the number of pizza lunches, and we've been calling that the number of students buying any lunch or total lunches. She decides to represent this expression using the variable t, so that t equals S plus W plus P. So that must be the total number of lunches sold. Let's see. What does T represent in terms of the school and the cafeteria? Record this information in the table, and it's no longer above. It's on my hyperlink. So what does T represent? I'm thinking T represents like the number of students buying any lunch or total lunches, something like that. Let's see. Number of students who buy any lunch in a day. And what's being measured there again? Students. Okay, or you could think of that as lunches served. So I kind of put that like that, just so we could see it in both ways. They say the same thing though. Okay, now where are we at? I think, was that number 7? Yes, it was. Okay, so T equals the number of students who buy lunch in a day. Great. And we recorded that information in the table already. So we are ready to go on to number 8. Elvira is having a meeting with the staff members who work in the lunchroom. She has created a couple of new equations for the food servers. Boy, Elvira, you'd be a great math teacher. Oh, and look at these equations. They look kind of complicated. D sub F equals T times P sub L divided by F. Wow. And then M equals M sub T divided by T. Looks like we're getting into advanced algebra here. Number 8. What does D sub F represent in terms of the school and the cafeteria? Okay, record this information in the table. Okay, so D sub F. Well, I need to know what T times P sub L would be. Now, wasn't T the total number of lunches sold times the price per lunch? Which, if that is the case, that would be the total revenue brought in. Let's see if we remember that, or do we need to go peek at the table? Yeah, daily revenue. And wasn't F the number of food servers? Let's double check that. F, number of food servers in the cafeteria. All right, there we go. So what would happen if we divided the daily revenue by the number of food servers? That'd be the daily revenue per food server, right? D sub F. You get it? Daily revenue per food server. Okay, so let's see how I wrote that out here then. Daily revenue per server. Great. Now, we probably better put that in the table. Daily revenue per server, and revenue, that's in dollars. Man, we're almost done with this table. And what was that, number 8 or number 9? Yeah, number 8. Okay. Solve this equation for P sub L. Okay, so we've got to take this complicated equation right here and solve it for the price per lunch. Describe why your solution makes sense in terms of the other variables. So here we go. If I'm going to solve for price per lunch, do you notice that the price per lunch is being multiplied by T and then divided by F, which is like multiplying by the fraction T over F. And to undo multiplication by a fraction, we simply multiply by the reciprocal of that fraction. There's my fraction. And there's the reciprocal of t over f over t. Now we do that so we can cancel out things like, look, do you agree that the f's now would cancel? And the t's now would cancel, leaving me my p sub l, which is what we were trying to solve for. So p sub l equals, and then what do I have on the other side? Nothing cancels over here. So I'm going to write this as one fraction. And I'm going to say f times d sub f divided by t. Now, does this make sense? F times d sub f. What's going on there? Well, f is the number of food servers, and d sub f would be the daily revenue per food server. Yeah, okay. And t is the total number of lunches sold. And if you forgot those, you can go back to that great table. Okay, so let's look at this numerator. The number of food servers times the daily revenue per food server. So that'd give me total revenue. And then the total lunches sold in a day. So total revenue over the total lunches sold in a day. That would give me P sub L. Guess what? Price per lunch. Let me go back and make sure. And we already have all of those defined. Let me double check. Yeah, price per lunch. We have all of that. Okay, great. All right, so that was number 8 then. We're good. Let's go on to number 9. Okay, now we're going to do the same thing it looks like with the second equation. M equals m sub t divided by t. So what does M represent in terms of the school and the cafeteria? Record this information in the table. Okay, now M. Well, I'd need to know M sub t and M sub t. Boy, we've dealt with a lot of variables. And M sub t, I better go check my table because I don't quite remember that. M sub t. The number of minutes it takes to serve lunch to all students. Oh, no wonder I don't remember that. We haven't used that one yet. The number of minutes it takes to serve lunch to all students. What was that, 9 or 10? Yeah, 9. Number of minutes to serve lunches to all students. And then wasn't T the total number of students who buy any lunch? So total lunches sold in a day. Okay, so let's think about this. Number of minutes to serve lunches to all students. So that's the total time divided by total lunches sold in a day. So wouldn't that M represent the time to sell anybody a lunch? So let's think about that. Minutes per lunch served. Good. Okay, now B. Solve this equation for t. So, all right. Now this t is in the denominator here. So if I'm going to solve for t, I have to multiply both sides by t. And then I'm going to have to get rid of that m on the other side. So I'm going to do this in one step. Can I just multiply both sides of this equation by t over m? Now, why did I do that? Now take a look here. The t's cancel, and over here the m's cancel. So what do I have? Solve for t. Doesn't t then equal m sub t divided by m? So let's write that out. T equals, and on the right over here I have my m sub t divided by m. Describe why your solution makes sense in terms of the other variables. So m sub t again was the number of minutes to serve lunches to all students. So the total time to serve all the lunches over m, and m was the minutes per lunch. So let's think about that now. M sub t again. Minutes to serve all lunches. M, minutes per lunch. Okay. Total time to serve all lunches, minutes per lunch. What's that going to make that t right there then? Total lunches sold in a day. Wow, how cool. Okay, so do we have that too? Let's make sure we have it in our table. T, number of students who buy lunch in a day. All right. What was that, 9 or 10? Well, let's check 9. Yep, that was it. Okay, so we've answered 9. It looks like we're off to our very last question. Number 10. One of the staff members suggests that they need to write expressions for each of the following. Using the variables in the table, that would, what would these expressions look like? Okay, the average number of students served each minute. Okay, now think about that. Average number of students served each minute. Now, wouldn't that be something like the total number of students served divided by the total time to serve everybody? So let's see. Total students served divided by total minutes serving. Okay. Now, total students served. Let's go back to the table. T, total. By the way, M, did we come up with something for M? I thought we did already. We better fill that in too while we're here. M, the number of minutes per lunch served, and that's time in minutes, so minutes. Okay, now we've got the table complete, so we can answer anything. So what were we looking at again one more time? I think it was the T was the number of students who buy lunch in a day. T, total students served, divided by total minutes serving. So that's the time to serve all the lunches all day. So let's go back. What did we use that? Total minutes serving. So number of students. Let's find minutes here. Number of minutes it takes to serve lunch to all students. That's that M sub T, isn't it? Let's double check that. M sub T, there it is. So one of the staff members suggests that they need to write expressions for each of the following. Use the variables in the table. What would these expressions look like? So the average number of students served each minute would be T, the total students served, divided by M sub T, the total minutes we're serving lunches. And then B, the average number of minutes students wait in the pizza line. Well, that'd be the total minutes serving over the number of pizza lunches that are sold, the number of students who buy pizza. So let's see, total minutes serving over students buying pizza. All right, so total minutes serving, well, that's my M sub T up there. And students buying pizza, didn't we just use a P for that? P, and there it is. Awesome. Now, I think that's it. Yeah, this is some extra activities I was going to have you guys do here, but that would be in class. All right, let's make sure our table is completely filled out. There it is. And I would make sure that I have access to this table because you know how these units work. We're going to come back to this probably several times. So with that, that is the lesson for 4.2. What was the title of that lesson? I want to sound very professional here. Okay, and it was what? Elvira's equations, if I remember right. Anyway, you guys, I hope you enjoyed that as much as I did. Basically, again, what are we working on? Defining variables and the units used to measure each variable, and then solving literal equations. Solving equations that have more than one variable in them for one of the variables. You guys, let's get our Ready, Set, Go done, and you guys have a great day.